What if we told you that everything you've ever known, every moment, every thought, every atom, is part of an unimaginably advanced simulation? Not a metaphor, not a theory, an actual structured system governed by precise mathematical laws, running on rules so deeply embedded that we mistake them for reality itself. Everything in our universe operates on predictable equations, from the way galaxies spin to the way cells divide. This isn't coincidence, it's computation. What we experience as physical reality is not truly solid, it is emergent, rendered, built upon fundamental mathematical structures. Space, time, and matter may not be the absolute constants we assume them to be. Instead, they behave like information, following predefined rules that dictate how energy and matter interact. The deeper we look, the more reality behaves like a constructed system, one that only reveals itself upon observation. Consider a video game. In a digital world, environments only render when the player is present. The game doesn't waste resources generating unseen details. Now apply this concept to the entire universe. We've discovered that light itself changes its behavior depending on whether it's being observed. At the smallest measurable scale, reality appears to be pixelated, suggesting a finite resolution, just like a digital display. There are hidden codes, ratios, and formulas embedded in everything, from DNA to the spirals of galaxies. This is not speculation. Physicists, cosmologists, and even intelligence agencies have explored the shocking implications of our universe being a programmed construct. In this presentation, we will explore the mathematical fingerprints of the simulation, the experiments that prove reality does not behave as it should, and the mind-blowing implications of what it means for us as conscious beings. Because if this universe is artificial, what's outside of it? Everything in existence follows strict mathematical patterns, suggesting design rather than randomness. If the universe were purely chaotic, why does it adhere to specific equations? The deeper we study reality, the more we find recurring numbers, ratios, and sequences embedded in nature itself. One of the most striking examples is the Fibonacci sequence. This sequence appears everywhere, in the spirals of galaxies, the structure of hurricanes, the arrangement of flower petals, and even in the DNA of living organisms. Each number in the sequence is the sum of the two before it. 1, 1, 2, 3, 5, 8, 13, 21, and so on. A sunflower follows this pattern in its seeds, ensuring the most efficient packing possible. A pine cone arranges its scales in spirals that match Fibonacci numbers. Even our own bodies follow these proportions. This sequence is not a coincidence. It is a fundamental part of the structure of reality itself. But the Fibonacci sequence leads to something even more profound, the golden ratio. The golden ratio, or phi, is approximately 1.618033, and it governs everything from art and architecture to the proportions of the human body. It appears in the spirals of galaxies, the growth of shells, the structure of DNA, and even in financial markets. It is as if reality itself was designed with this ratio as a guiding principle. If the universe were purely random, why would it consistently adhere to such an elegant, precise mathematical rule? These patterns suggest that reality does not just contain mathematical structure, it is built upon it. The universe is built upon self-repeating, scalable structures, patterns that emerge at every level of reality. These are known as fractals. A fractal is a pattern that looks the same no matter how closely you examine it. It repeats infinitely, from the largest cosmic structures to the smallest biological formations. Snowflakes, lightning bolts, river networks, coastlines, lungs, neurons, and even the way galaxies cluster together all follow fractal geometry. It is as if reality itself is running on a recursive algorithm, where smaller structures mirror larger ones in an infinite cascade. This is exactly what we would expect in a simulation, an efficient rendering system where complex patterns emerge from simple mathematical rules. But what if the universe itself has a resolution limit? At the smallest possible level, space and time appear to be pixelated, as if they exist on a discrete grid rather than a smooth continuum. This limit is known as the Planck scale. The Planck length, 1.6 times 10^³ 5 meters, is the smallest possible measurement of space. Anything smaller than this simply ceases to have any meaning. In other words, reality is not infinitely divisible. There is a point where everything breaks down into fundamental units, like pixels on a screen. This suggests that space-time itself is not continuous, but quantized, just as we would expect in a programmed environment with processing constraints. Physicists have even proposed that math doesn't just describe the universe, it is the universe. The mathematical universe hypothesis suggests that everything we perceive as physical reality is actually an expression of pure mathematical relationships. If the fabric of reality reduces to equations, ratios, and information, then what is our universe other than a vast computational system? A system that behaves not like a chaotic, random explosion of matter, but like something designed, governed by logic, efficiency, and precision. And if the universe is structured this way, who or what designed the code? Light is one of the most mysterious elements of our reality. It exists as both a wave and a particle, until it is observed. This strange behavior was first demonstrated in the famous double-slit experiment. When scientists fired single photons or electrons at a barrier with two slits, they expected the particles to travel through one slit or the other, like tiny bullets. But when no one was watching, something strange happened. Instead of behaving like particles, the photons passed through both slits simultaneously, creating an interference pattern on the screen behind them, exactly like a wave. It was as if each photon was in multiple places at once, existing as a probability wave instead of a single particle. But the moment scientists placed a detector at the slits, watching which path each photon took, the behavior changed. The interference pattern disappeared. The photons no longer acted like waves. Instead, they behaved like solid particles, choosing only one slit to pass through. Somehow, the act of observation forced reality to make a choice. This defies logic. Why would a photon know it was being watched? It suggests that reality does not exist in a definite form until it is observed, as if the universe is waiting to render information only when necessary. This is exactly how a simulation works. In video games, environments are not fully rendered at all times. The game only processes what the player sees, saving computing power by not generating unnecessary details. So why would our universe behave the same way? Could it be because, at its core, our reality is not physical but informational? Reality should be fixed. The past should not change based on choices we make in the present. But quantum mechanics suggests otherwise. The delayed choice quantum eraser experiment takes the bizarre results of the double-slit experiment even further. It doesn't just show that observation affects reality, it suggests that our choices in the present can retroactively determine the past. Here's how it works. Scientists fire a single photon at a barrier with two slits, just like in the double-slit experiment. The photon then continues toward a detector that will record its final position. But this time, an extra step is added. Before reaching the detector, each photon's path is split into two possible routes. In some cases, the path information is immediately erased before detection. In others, the path is recorded before the photon reaches the final screen. If the path information is erased, the photon behaves like a wave, passing through both slits simultaneously and creating an interference pattern. But if the path is recorded, the photon behaves like a particle, choosing only one slit to pass through. The strange part? The decision to erase or record the photon's path is made after the photon has already passed through the slits. Yet somehow, the photon's behavior changes retroactively, as if it knew whether its path information would be erased in the future. This suggests that the past is not set in stone. Instead, it seems to be rewritten in real time based on present information, just like a computer recalculating past frames in a simulation when new input is received. If reality were truly physical, this would be impossible. But in a simulated universe, where information is the fundamental unit of existence, it makes perfect sense. Could it be that time, as we perceive it, is just another illusion? Light from distant galaxies has traveled for billions of years to reach us. We assume that the photons from these galaxies have been traveling in a fixed state since they left their source. But quantum mechanics tells us something far stranger. The light's behavior is not determined until we observe it. Just like in the double-slit experiment, where a photon's state collapses upon measurement, the light from galaxies billions of light-years away does not settle into a definite state until it reaches our telescopes. This raises a disturbing question. Was the universe in a quantum superposition before we looked at it? If light behaves as both a particle and a wave, choosing its state only when observed, then that means the structure of the cosmos itself is not fully rendered until a conscious observer interacts with it. This is not just theoretical. Scientists have conducted experiments measuring starlight passing through cosmic lenses, gravitational warping caused by massive objects like galaxies. They found that the behavior of photons depended on whether or not they were being observed, even though they had been traveling for billions of years before reaching Earth. This suggests that reality itself is observer-dependent, even on a cosmic scale. If the universe were truly physical, its structure should be independent of our observation, but if reality is computational, then it makes sense. It operates like a simulation, only processing details when they are required. If this is true, then the most distant galaxies, the vast cosmic voids, the unseen corners of the universe, may not even exist in any definite form until we observe them. So we must ask ourselves, are we discovering the universe, or are we creating it? Empty space is not truly empty. For centuries, we imagined the vacuum of space as an absolute void, silent, motionless, and completely devoid of energy. But quantum mechanics tells us that even in the most desolate regions of the cosmos, reality is far from still. This is due to quantum vacuum fluctuations, a phenomenon where virtual particles spontaneously appear and disappear in empty space. These particles emerge out of nothing, exist for a fraction of a second, then vanish before they can be directly observed. This might sound impossible, but it has been experimentally verified. Scientists have measured the effects of these quantum fluctuations in the laboratory. The Casimir effect demonstrates that virtual particles exert a real, measurable force, proving that empty space is constantly shifting and fluctuating at a microscopic level. This discovery forces us to rethink what we call reality. If space itself is not a fixed, stable structure, but rather a shifting sea of ephemeral energy, then what does that say about the fabric of the universe? A perfect simulation would not waste resources generating a static, unchanging environment. Instead, it would dynamically calculate and adjust reality as needed, just as quantum fluctuations suggest. Could it be that what we call existence is not a solid, fundamental state, but a constantly updating system of information? And if so, who or what is running the program? In modern video games, entire worlds exist, but they are not rendered all at once. Instead, the system only generates what the player sees. The landscape in the distance remains in low resolution or doesn't exist at all until it becomes relevant. This technique conserves processing power while maintaining the illusion of a fully immersive environment. Now consider this. What if our universe operates on the same principle? Quantum mechanics suggests that reality is not fully determined until it is observed. In video games, objects remain in a low-detail state, or aren't loaded at all until the player approaches them. Likewise, quantum particles exist in a state of probability until they are measured, at which point they collapse into a definite form. This is exactly what we would expect in a simulated environment. Imagine walking through a vast digital world. The moment you turn your head, new objects load into existence while those behind you fade into lower detail. The computer does not waste resources processing what isn't being observed. In our universe, the behavior of subatomic particles follows the same rule. Until an observer interacts with them, they remain in an undefined state. The simulation only generates the information when needed. If reality functioned like a traditional, purely physical system, everything should exist in full detail at all times. But that's not what we observe. Instead, reality behaves as if it renders only what is necessary, efficiently managing its resources like a computer program. This raises an unsettling question. If the universe operates like a simulation, then what or who is running it? The deeper we investigate reality, the more it appears to be an artificial construct. Even intelligence agencies have explored this concept. Declassified CIA documents suggest that consciousness may have a direct influence over reality itself. If thought alone can affect the physical world, then what we perceive as solid matter is not truly solid. It is flexible, reactive, an information system responding to inputs. Some researchers propose that our universe is not just a simulation, but a holographic projection, a vast stream of encoded data displayed on the inner surface of a black hole in a higher dimensional space. This would mean that everything we experience, time, space, physical laws, is not fundamental, but a secondary effect of a deeper computational framework. The conclusion is unavoidable. Reality is not what we thought it was. The universe operates under rules, constraints, and optimizations that are characteristic of a programmed system. Every observation, every experiment, every equation points toward the same truth. This universe is artificial. Which brings us to the final, most unsettling questions. If this is a simulation, what does that make us? Are we merely constructs inside a grand computational system, or are we avatars of an external intelligence? Can we modify the simulation from within? Are we part of a grand design, an experiment, or something else entirely? And the most important question of all, what exists outside the simulation? Want more mind-bending science, theory, and exploration into the unknown? Like and subscribe.